Form and complete a full hypothesis test for the mean with population standard deviation known, the critical value approach. First, let's read our question. George, an economist, is studying income data and would like to test the claim that the salary for recent college graduates in a metropolitan city is less than $50,000 on average. Remember that $50,000, we're going to need it. He decides to complete a hypothesis test at a 10% significance level. He samples 36 recent college graduates in the metropolitan city and determines the sample salary to be $47,000. Assume the standard deviation is sigma equals $7,000. Let's work through the test procedure and interpret the results of the hypothesis test. Remember, those steps are to identify the null and alternative hypothesis, decide on the significance level, compute the test statistic, find the p-value, and then interpret the results of the hypothesis test. Let's jump in. First, to identify the null hypothesis and the alternative hypothesis. We know about George and his income data. The big key is that we're looking at less than $50,000 on average. Recall that the null hypothesis is always the equality. So our H sub 0, null hypothesis, is going to be mu equals 50. And because George is looking at less than $50,000 on average, then our alternative hypothesis is going to be mu is less than 50. This is what we are trying to show. So let's now decide on the significance level, number 2. They tell us it's 10%, so that gives us alpha is 0.10. That's going to be needed for us to find the critical value. To compute this test statistic, we need all of the data. So remember that 50,000 that we talked about initially, because that is our given value. We know that he samples 36 college graduates, determines the sample salary to be 47,000, and then we have the standard deviation. So X bar, the sample mean is 47. As we mentioned, the given mean is 50, right? That's what we're testing. We know the standard deviation is 7 and our sample size is 36. I highly recommend you write these out. Identify the key values given in your statement. Once you have your key values, you recognize your formula for computing the test statistic. Because we know the population standard deviation, we are looking at a z test statistic. So we have our z sub 0 equals x bar minus mu sub 0 divided by sigma divided by the square root of n. We plug in our values appropriately. Use parentheses in your calculator. Make sure you're following the order of operations. And we end up with our test statistic of negative 2.57. So with the critical value method, we are going to compare that test statistic to our critical value. So step number 4, find that critical value. So we are given standard numbers here. Now, these are for one-tailed tests because all of the area in a one-tailed test is focused on one side. If we have a two-tailed test, we're going to have to split it because it's symmetrical. So in a significance level of 0.10 in a two-tailed test, there would be 0.05 in each tail. Now, for our case, we're talking about a less than alternative hypothesis, which means this is a left-tailed test. And we know that our significance level is 0.10, so we can look at our table and see that the critical value is 1.282. However, as I've already mentioned, this is a left-tailed test, so that critical value is going to be a negative 1.282. Now we can compare. We want to compare the test statistic to the critical value. And for a left-tailed test, if the test statistic is less than the critical value, we should reject the null hypothesis. So the test statistic of negative 2.57 is less than the critical value of negative 1.282, so we will reject the null hypothesis. If we're rejecting the null hypothesis, that means at the 10% significance level, the data provide strong evidence for George to conclude that the salary for recent college graduates in a metropolitan city is less than $50,000. Because rejecting the null means that we have enough evidence to support the alternative hypothesis, and in this case, it's less than $50,000 on average.